Hello guys. Now in previous lecture we discuss on matrix and some basic of matrix and types of matrix. Now in previous lecture we learned elementary transformation. Now in this lecture we learn rank of matrix. Now learning objectives of this lecture, you will be able to use elementary transformation of matrix, determine row echelon form and find the rank of matrix. Now row echelon form of a matrix. Now we see the properties of row echelon form. A matrix A is said to be in echelon form if it satisfies the following properties. Now first property, every zero row matrix A occurs below a non-zero row. Now what is meant by zero row? Means all elements are zero in that row is called zero row. Now second property, the first non-zero number from the left of a non-zero row is 1. This is called leading one. Now third property, for non-zero row, the leading one appears to the right and below any leading one in the preceding row. Now let us see example. First example, the matrix is first example, matrix is 3 by 3 matrix. There are 3 row and 3 column, therefore it is called as 3 by 3 matrix. Now first matrix is in row echelon form because it satisfies all the 3 properties. Now the zero row should be present below all the non-zero rows and below all the diagonal elements all entries are 0. Therefore first matrix is in echelon form. Now the same thing in second, or there is no zero rows, all are the non-zero rows, but below all the diagonal elements there are 0 entries, therefore it is in echelon form. Now take one example, determine whether the following matrix is in echelon form or not. Now this is the matrix. Now check whether this matrix is in echelon form or not. Now the solution is yes, because all the non-zero rows present below the non-zero rows, it satisfies the first property, and below all the diagonal elements all entries are 0, therefore it is in echelon form. Now take second example, check same, it is in echelon form or not. Now let us check all the properties. Now there is no zero rows and below all the diagonal elements. Now for the first diagonal elements there is entries are 0, but not for second diagonal element, therefore it is in not echelon form, therefore the solution is no. And for third example, there are 2 zero rows, but first zero row present upper the non-zero rows and which does not satisfy the property 1, therefore it is not in echelon form, therefore the solution is no. Now let us go to the definition of rank of matrix by echelon form. The rank of matrix in echelon is equal to the number of non-zero rows of the matrix. Count the non-zero rows in a matrix and it is the rank of that matrix. For example, let us take one matrix, A matrix, and the matrix is 1 minus 1 3 0 1 4 0 0 0. Now there are 2 non-zero rows. First row is 1 minus 1 3 0 1 4, therefore the rank of matrix is 2, and it is denoted as the simple row of A is equal to 2. Means it is the rank of A is equal to 2. Now we go to the second example. Find the rank of following matrix by reducing it to an echelon form. Now we have to convert this matrix into a echelon form. For that matrix, we convert or we arrange all the diagonal elements should be a 1. Now here first diagonal element is 5. Now we have to make that 5 is 1. We apply transformation for make it 1. Now in third row 1 is present, therefore we interchange. Now take a solution. Let a given matrix is A. Now reducing the matrix A to echelon form, apply R13. R13 means we interchange row 1 with 3. Now we get equivalent matrix. This symbol is for equivalent and it is not exact or equal to a given matrix because we do the elementary transformations. Therefore 1 minus 1 2 0 0 1 2 1 5 3 14 4. Now we see the properties of row echelon form and we have to convert the given matrix into echelon form. Therefore we have to change below all the diagonal elements, all the entries are 0. Now here first diagonal element is 1 and below that diagonal elements there is in second row there is a 0. Now in third row there is a 5 and that 5 we have to change to 0. Therefore we apply a transformation R3 minus 5 R1. Now after solving, what is meant by R3 minus 5 R1? Now we change in R3 by using this transformation, not change in R1. We only change in R3. Therefore we write R3 first and after that the usual addition or subtraction R3 minus 5 R1. Now it change only in R3, not in R1. Therefore the first row is same, 1 minus 1 2 0. We cannot change R2. Therefore the same thing 0 1 2 1. Now change in R3. Therefore the new row is 0 8 4 4. Now the below the first diagonal elements all entries are 0. Now our now next we do the all below the second diagonal elements all entries are 0. For this now here now second diagonal element is 1 and below that 1 8 is present. Now we have to do this 8 to a 0. Now for this we use a transformation. Now we apply R3 minus 8 R2. Now after that solving this transformation we get a new R3 0 0 minus 12 and minus 4. Now this is in echelon form. If we want here instead of minus 12 we divide or we multiplied by minus 1 by 12, then we get a new row 0 0 1 and 1 by 3. Now we get a matrix in echelon we reduce the given matrix in echelon form. Now from this echelon form we find out the rank of matrix. Now the given matrix is reducing echelon form and there are 3 non-zero rows. Therefore the rank of A is 3. Now you got this. Okay. Now after this summary, given any matrix of order m cross n, reduce that matrix using only row transformation into row reduced echelon form, that is below the diagonal elements make all elements to be a 0. And remember the definition of rank. Rank is nothing but the total number of non-zero rows of the matrix. and rank of matrix is denoted by the symbol row of A, that is rank of A. And this is the reference for practice.